Let's see how we can create a generative AI model in 12 minutes with Domino Data Lab and NanoGPT. You will need access to GitHub. You will need to be able to configure an environment based on NVIDIA's NGC. And we will also use the Illiad as our custom content for content generation with NanoGPT. The first step would be to create a new environment. We'll do that by clicking this button here and give it a name. We will start with an NVIDIA environment, as I mentioned, from here, which include PyTorch, which NanoGPT depends on. We will also make sure to keep the automatically make compatible with Domino checkbox checked in order to ensure that all the tools that we need will be available. We will also customize the environment before building it, and we will install several packages that the model relies on. Once we do that, we can click on build, which will take a few minutes and that we will skip in this video. Now that the environment is ready, let's go ahead and create a project. To do that, I just create a project here. And click create. And now let's create a workspace using the environment that we just defined. So there, here, and since we are going to accelerate things with the GPU, I will use a GPU instance here. Now that Domino has started, let's start by downloading the GitHub repository for NanoGPT. We will do that by using git clone. And now we will have the repo available. The repository uses a collection of Shakespeare's works as the demo input data. And the first step to enable that is to run a preparation script that will download and then tokenize that content. And that was that. Now, now that we have the content, we need to train the model on it. So train.py, and we will use a configuration file that is available in the config directory. Based on the type of GPU that you are using, you may encounter an error such as this. Dealing with it is pretty simple. There are two files. One is train.py, where you will find a mention of bfloat here in D type. You just change it and save it here, and the other one is in a file that we will encounter a little bit later on called sample.py, and again we will need to change the data type. If you're using a more recent GPU, I'm using a V100, you may not encounter this issue, but again, if we try this, what we will encounter is that the training process actually is, as expected, starting. And while it is running, one of the steps is to use PyTorch compilation to compile the model in order to improve its performance. While this is running, I will mention that you can also change the way that training takes place to not use a GPU and instead use a CPU. The information is again in the config folder in this file where you can just uncomment these two lines. In the meantime, the model is compiling, and in a few seconds I will just accelerate the time that it will take. In each training iteration, the model will undertake 5,000 iterations, so it will take a few seconds. And we're about to hit 5,000 iterations, and our model will be trained. The last step now is to actually ask it to generate some text for us. So we'll use the sample script, which we updated a moment ago, and use the argument to tell it to use the out Shakespeare char folder. You can see the model is 10.65 million parameters, and we are generating some Shakespeare, which is great. Now, as a second part, let's try and make this model our own. So to start, let's make a copy of the data folder where the Shakespeare text was downloaded. So we'll simply do copy, so copy data, and into a folder that we will call data. And since we're using Homer's work, we will call it Homer. Okay, and now let's edit the file that we copied, prepare.py, and instead of going to Tiny Shakespeare, we will actually go to a bit.ly address that we created, but which goes to Project Gutenberg to download the content. So that's the first step. The second step is that we need to remove the input.txt because that's the file where the data was downloaded into, and we need a fresh one. And now let's just run that. So let's, instead of this prepare.py, we are actually going to go to Homer. And it will download, and as you can see, there's even some Greek characters in the text. We now need, and you see also the input.txt file was regenerated. Another file that we need to change is the config file. And again, we will use the train.shakespeare one, but now we will save it as Homer. So instead of train Shakespeare char, we will save it as train Homer char. What we need to change here are just two things. The output directory for the model, which we'll call Homer, out Homer, sorry. And the other thing that we need to change is that the data set is called Homer, because that's where we saved our model. So going back to our command line, let's run the training again. Sorry, python.py, and again we will have config, but this time we'll use train homer.char. See if that works. And yes, we are compiling the model, and again I will accelerate the process in the video. Okay, and you can see that we finished training the model on our Illiad data, and the final step is to actually see if we can generate a sample. And you will notice that instead of the out there that was Shakespeare, now we are going to have a Homer output directory. What just happened to us? Here we go. Let me just check. And actually, I just called it out Homer. So there we go. Lots and lots of fake Greek translations, names, and all in the fine style of the Iliad. So thank you for joining us for this demo, and we hope to see the amazing things you do with generative AI on the Domino platform.